It's 1:15 in the morning. You're sitting entirely alone in a dead, silent desert laboratory, and just 6 feet away from you sits a 14-pound sphere of pure, unshielded plutonium. It's radiating this faint, unnatural heat. It's literally ticking. If you make one wrong move right now, or if you even just look away for too long, it's going to kill you in a blinding flash of blue light. So what happens when human hubris meets cold, indifferent physics? Let's dive into the terrifying, true explanation of the demon core. Okay, picture this. It's deep into the night, 1:15 a.m., and the silence out there in the New Mexico desert is absolute. But inside the lab, something is wrong. A single, heavy tungsten brick has just moved, entirely on its own. It's this tiny, invisible shift, but it's pushing this completely isolated room straight toward a lethal nuclear flash. And the only person who can stop it is a young physicist who's rapidly running out of time.
So let's set the scene here. We're in Building V at Los Alamos. It's a sweltering summer of 1946, and it's the grueling night shift. We're talking 8 p.m. to 4 a.m. Sharp 29-year-old MIT grad Dr. James Callaway is sitting there, totally alone in the suffocating silence. You know the war is over, right? But the absolute most dangerous materials on planet Earth have just been left behind in ordinary-looking rooms exactly like this one.
And sitting just 6 feet away from him is a sleeping monster. They called it the demon core. It's a 14-pound, silvery gray sphere of pure radioactive power. They actually salvaged this thing from the Fat Man device. It's just sitting there in a precisely machined cradle, radiating this really eerie, unnatural warmth. It's quietly, politely decaying. Think of it like a tiny, contained sun just waiting in the dark. Now, before Callaway took on this incredibly isolating shift, his supervisor gave him one very specific, bone-chilling instruction. He literally said, "Don't let it out of your sight, and don't do anything creative." That's it. Then he left him entirely alone in this dimly lit room. And you gotta understand, that instruction wasn't just some standard lab protocol. It was literally a matter of life and a very, very painful death. Because that warning, it carried some gruesome history. See, just 8 months earlier, a brilliant physicist named Harry Daghlian was working right there on this exact same core. And he accidentally dropped a single tungsten carbide brick onto it. Just slipped from his hand. That one tiny mistake triggered an instant massive radiation spike. Daghlian actually managed to stop the reaction barehanded, but, well, it was too late. He caught a lethal burst of radiation and died in absolute agony 25 days later. You know, the true psychological horror in that room wasn't ignorance. These guys were literally the smartest minds on the planet. The real terror was complacency. It's that creepy, creeping danger of staring at a deadly anomaly every single day until it just feels ordinary. Until you completely forget that you're sitting next to a loaded gun with a hair trigger. And this terrifying temptation actually rears its head on Callaway's third night. Get this, a reckless senior scientist drops by in the dead of night and casually suggests they run an off-the-books experiment. He literally wants to use a standard flathead screwdriver to prop up a beryllium dome right over the core, basically teasing the dragon right up to the absolute edge of a runaway chain reaction. Seriously, what happens when human hubris meets a sleeping sun? Well, thankfully, Callaway doesn't find out that night. He flat out refuses to play games with this monster. So the senior scientist leaves, and Callaway painstakingly documents this totally nerve-wracking encounter in his logbook. You can imagine his heart is just pounding in that suffocating quiet. He survived the temptation, right? But the core wasn't done with him yet. Because the real terror actually strikes on his fourth night. It's Friday night, 1:15 a.m. He's in the 5th hour of this grueling shift, which is exactly when your mind starts to slip and the fatigue really sets in. But the silence of the lab isn't broken by a reckless human this time. It's broken by the subtle, cold, indifferent realities of physics. So Callaway's just doing his routine checks. Normally the baseline neutron multiplication in the room sits at a safe, steady 2.3. That's what you want to see. But Callaway looks up at the instruments, and the number has inexplicably climbed to 2.7. In the dead of night, with nobody else around, something in that room has changed and the radiation is rising. Fast. He starts searching the room in an absolute cold sweat. He's checking the temperature, checking the humidity, and then he looks at the shielding around the core itself. He realizes that a slow, low-frequency tremor from the daytime ventilation system has been vibrating through the concrete floor for hours, and that tiny, continuous vibration, it managed to nudge a deadly tungsten shielding brick just 0.75 inches out of place, literally 3/4 of an inch.
That imperceptible, totally microscopic shift was bouncing deadly neutrons directly back into the plutonium. It was silently waking the sleeping monster. It was inching the core closer and closer toward an uncontrolled, lethal chain reaction, all while Callaway was sitting just a few feet away, completely unaware.
Okay, so one wrong move right now, it's a guaranteed death sentence. Fighting back this blinding panic, Callaway remembers his training. Step 1, step back. Don't do anything hasty. Step 2, he takes 3 slow breaths and visually calculates the deadly geometry of the setup. And step 3, he carefully grabs a specialized long-handled tool to slide that heavy tungsten brick away from the absolute brink of disaster.
As he slides that brick back into its exact designated place, you can see the lethal numbers on the counter finally start to drop. It inches down from that terrifying 2.7, sliding to 2.4, and finally, mercifully, it rests safely back at the 2.3 baseline. The monster goes back to sleep.
Callaway actually survives the night, but the sheer horror of how close he came prompts some massive, immediate action. He writes this incredibly detailed 12-page report that forces a complete safety overhaul. We're talking mandatory minimum 2-person staffing, installing heavy-duty vibration dampening, and requiring instrument readings every 30 minutes. He made sure no human being would ever be allowed to face the core alone in the dark again.
As for the physical demon core itself, it was ultimately melted down in the spring of 1947. They repurposed the plutonium, and that specific, terrifying metallic sphere officially ceased to exist. But the memory of that ticking, indifferent sphere just waiting in the dark for a single mistake, that haunted Dr. James Callaway for the rest of his life.
And here is the truly shocking twist to all this. The reality of that night can be summed up in Callaway's own chilling conclusion. He wrote, "The core doesn't care about your intentions. The danger is always human." Think about that. The core was never a malicious monster. It was just patient, indifferent physics, doing exactly what physics does. The real horror? The horror was always us. If you want to survive more terrifying true stories and explore the dark, chilling side of history with us, make sure to like this explainer and subscribe to our channel right now. Honestly, let us know down in the comments, do you think you could have survived a night alone with the demon core? Picture this. You're standing in a freezing, claustrophobic basement. It's just you, 6 other people, and a silent, heavy cylinder of uranium sitting perfectly still under black water. You're just doing your job. But what you don't know is that you are literally fractions of a millimeter away from your flesh melting and your DNA unraveling. Welcome to the Chicago Warning. We build these invisible cages to hold back literal apocalyptic forces, and we trust math to keep the cage doors shut. But what happens when the math is dead wrong? So seriously, ask yourself, what is the exact physical distance between you and a horrific, agonizing death? Like right now, we all kind of walk around assuming that distance is huge, right? But in the darkest, coldest corners of our scientific history, that distance wasn't measured in miles. It wasn't even measured in inches, guys. It was measured in fractions of a single millimeter. Today in this explainer, we're going to dive into one specific, terrifying instance where humanity almost crossed that invisible line. All right, let's set the scene. It's November 1952, Chicago. The whole city is wrapped in this gray, bone-chilling cold. The wind whipping off Lake Michigan feels like it actually has some sort of dark intent. And deep beneath the soot-stained Gothic limestone of the University of Chicago, you'll find the Critical Materials Research Division. Down in the basement of Eckhart Hall, you have these incredibly brilliant minds working in unforgiving, claustrophobic proximity to materials that could literally kill them all if they lose focus for even 30 seconds. At the core of this whole nightmare is a clash between 2 very distinct minds. On one side, there's Dr. Arthur Brennan. He's the division director, 53 years old, deeply cautious, and wearing this permanent, severe mask of concentration. Honestly, it's a survival mechanism in his line of work. Then, on the other side, you've got Dr. Vincent Aldridge. He's 35, a Harvard PhD, intensely confident and, well, objectively brilliant. And this right here is where the creeping dread really starts. Because in the world of nuclear physics, you know who the most dangerous people are? The absolute smartest ones. They are so incredibly used to being right, they kind of just stop entertaining the possibility that they could ever be wrong. So, Dr. Aldridge pitches this proposal, the Chicago Proximity Study.
Let me break this down into plain English. He wants to take a highly reactive, deadly core of uranium-235, submerge it in a precisely machined tank of water, and then measure how that water reflects neutrons back into the core to multiply its power. Basically, he wants to bring the water uncomfortably close to the core to get data nobody else has. He is, for all intents and purposes, building a very fragile, watery cage to poke a sleeping monster, just to see how much it flinches.
Now take a look at the terrifyingly small margin we're dealing with here. Aldridge wants to push this water reflector to a gap of just 8 millimeters from the uranium. At that specific distance, his theoretical models predict a neutron multiplication factor of 0.96. Okay, but here's the catch. A factor of exactly 1.0 means criticality, an uncontrolled lethal nuclear chain reaction. The margin of safety keeping every soul in that room from a horrific death is just 0.04 of a point. It's this microscopic, invisible margin built entirely on the massive assumption that Aldridge's math is absolutely, flawlessly perfect.
Well, Dr. Brennan looks at this proposal and his blood just runs ice cold. He immediately challenges Aldridge. Of course, Aldridge gets defensive, insisting his models are pristine, the cross-section data is the best in the world, everything's been independently validated, but Brennan just looks him dead in the eye and drops this chilling reminder. He says, Harry Daghlian's calculations were validated, and a man is still dead. For context, Harry Daghlian was a physicist at Los Alamos who accidentally dropped a single tungsten carbide brick onto a plutonium core. He died an agonizing death from radiation poisoning 25 days later. So Brennan absolutely refuses the 8 millimeter gap. He flat out demands the minimum distance be pushed back to 15 millimeters.
Fast forward a bit to January 1953. The Chicago winter is absolutely brutal. This basement lab in the annex is freezing, barely hitting 60 degrees. It's this claustrophobic tomb of exposed concrete with these overhead pipes that clank unpredictably in the dead silence. And sitting right in the center of this room is the assembly. A silent, heavy uranium cylinder just resting beneath the flat, dark surface of the water. Waiting. Just waiting. Because one single mistake in this freezing room means every single soul inside will be bathed in a lethal, invisible fire.
Right before they begin, Aldridge actually addresses his team, having finally realized why Brennan was so paranoid. He tells the room that the gap between the uranium and the water isn't just some math on a chalkboard. He says it is the physical distance between this room as it is right now and this room after an uncontrolled criticality event. That distance has to be large enough to contain every error we haven't thought of yet.
So the procedure itself is this methodical, nerve-wracking descent into danger. Step 1, you carefully, slowly lower the water level. Step 2, you inch toward that new 15 millimeter minimum gap. And step 3, you hold your breath, watch the instrument stabilize, and record the data. Think about it. 7 people trapped in a basement, slowly draining water to expose a core that desperately wants to wake up.
For the first 2 days, the tension is just suffocating, but the experiment goes beautifully. The numbers match Aldridge's models perfectly. It's a symphony of mathematical precision. But then we hit day 3. It's 2:17 p.m. The water level is at 19 millimeters above the core, so still 4 millimeters away from their target gap. And suddenly, violently, the symphony stops.
The dead silence of the basement is broken by just 2 words from Michael Kwan, their brilliant, meticulous instrumentation chief. He just says, softly and incredibly steadily, Dr. Aldridge. Now, Kwan is a guy who reads instruments the way a musician reads sheet music. He doesn't panic, he doesn't shout. But hearing those 2 quiet words instantly freezes the blood of every single person in that room. Brennan's head snaps up. Aldridge rushes over.
The sheer terror here lies in a microscopic discrepancy. The primary neutron counter reads 0.91, which is exactly what Aldridge's flawless math predicted. But the secondary independent verification counter, it's reading 0.93. That is 2/100ths of a point higher than it should be. 2/100ths of a point higher than physics says is mathematically possible at this distance.
Aldridge orders an immediate, full halt. Nobody breathes. Nobody touches a single thing. The water sits perfectly still over that deadly core. Kwan asks for 40 minutes to manually verify the calibration of both counters without disrupting the experiment. What follows are 41 agonizing frozen minutes. 41 minutes where life and death hang completely suspended in the frigid basement air, while 7 people literally stand there wondering if they're already dead. Finally, Kwan looks up from his instruments and delivers the absolute worst-case scenario. The secondary counter is accurate. The primary counter has a calibration drift. Guys, the psychological gut punch of those words is unimaginable. It means the primary counter has been lying to them. It means Aldridge's beautiful, perfect, peer-reviewed model, the absolute mathematical certainty they had trusted their very lives to, is wrong. The monster is waking up way faster than they thought.
Brennan demands immediate recalculations based on this terrifying new reality. They are quite literally mapping the abyss in real time. Aldridge is scribbling frantically on his notepad. If they proceed to the 15mm target, the new prediction isn't safe anymore. It jumps to 0.95. If they were to push to 12mm, it hits 0.98. That is just 0.02 of a point away from a nuclear flash.
And then, Brennan asked the question that haunts this entire story. What about the original target? What if Brennan hadn't forced Aldridge to change the original plan? What if they had actually gone down to the 8mm gap that these brilliant physicists were so utterly confident in? Aldridge looks at his notepad. His voice is completely dead. 1.01. If they had followed the original plan, the core would have gone critical. The room would have instantly flooded with a lethal blue flash of radiation. Every single person in that freezing basement would have suffered a horrific, agonizing death.
Brennan immediately halts the experiment's descent right then and there. He establishes a new, hard boundary, 22mm. They do not go a fraction of a hair below 22mm. Because of that sudden, forcefully imposed revision, disaster is averted. All 7 people walk out of that claustrophobic concrete tomb alive.
Which brings us to the aftermath and the lesson of the honest instrument.
2 months later, in March 1953, Brennan stands before a lecture hall packed with the next generation of nuclear physicists. Now, the exact details of the Chicago proximity study are highly classified, so he can't tell them exactly how close they all came to melting, but he delivers this seminar, providing a chilling psychological autopsy of human arrogance. He breaks it down like this. Theoretical models? They're human constructions, infected with human flaws and blind spots. Professional certainty is incredibly dangerous because it just breeds blind complacency. But the instruments? Instruments don't have egos. They don't have careers to protect. They don't have a deep desire to be right. When your brilliant mathematical model disagrees with the physical instrument, the instrument is the only honest voice in the room. The instrument is reality. Brennan looks out at this crowd of students and leaves them with the terrifying math of survival. 0.02. 0.02 of a point. It's a number so microscopic, so utterly insignificant, that most brilliant minds would simply write it off as background noise. They would dismiss it, push forward, and die. 0.02 of a point was the exact, invisible boundary between a quiet January afternoon and an agonizing death. And he leaves them with this final, haunting warning, hoping it echoes in their minds every time they step into a laboratory. He says, "The margin is not a technicality. The margin is the physical space between the world you are living in and the world you are trying not to create. Respect it as such, protect it as such, and never, under any circumstances, let familiarity convince you that it is larger than it is." The monster in the basement is always sleeping, but it takes only a fraction of a millimeter to wake it up. So ask yourself, what invisible margins are you blindly trusting your life to today? If this explainer terrified you and you want to peer into more of the dark, razor-thin margins of our world, do not forget to like and subscribe.
You are sitting in a sweltering room in the Nevada desert. Suspended right in front of you is a heavy metal shell, slowly descending over a sphere of highly unstable plutonium. If that shell drops literally a fraction of a millimeter too far, a runaway chain reaction triggers. A blinding flash of blue light hits you, and everyone in the room is instantly vaporized. The scariest part? The smartest physicists on Earth are looking at their math, and they are promising you it's perfectly safe. But they're wrong. There's a microscopic miscalculation hiding in the equations. Today we're looking at a terrifying true story from the Cold War, where a tiny discrepancy was the only thing standing between a room full of brilliant scientists and a localized nuclear apocalypse. Let's dive right into this nightmare.
0.01. 1 single hundredth. I mean, it's basically nothing, right? A rounding error, but you need to burn this exact number into your mind, because this tiny, terrifying decimal is the absolute monster of our story today. This exact microscopic margin was literally the only thing standing between a research team and complete vaporization. So, how on earth did humanity ever cut survival this incredibly close? Well, to understand that, we have to travel back to one of the most unforgiving places on the planet. It's July 1955. We're deep in the Nevada desert. And as one person put it, it featured a sky so indifferent it genuinely made you dizzy. It is 107 degrees outside. The scrub land is just this flat, brown, totally silent expanse. But the wind is what's truly unsettling here. It brings zero relief. It's just this hot, dry blast of air that carries a faint, disturbing metallic taste. A taste that literally no one working at the inner range of the Nevada test site ever dared to mention out loud. And deep inside this hostile wasteland, locked inside a highly classified structure known as Building 12, a small group of human beings were about to play Russian roulette with the fundamental laws of physics. Now, the team assigned to this project, Operation Sandstorm, they were already pushed way past their human limits. You've got Dr. Eleanor Marsh, the lead physicist. She hasn't had more than 6 consecutive hours of sleep in 18 months. Her deputy, Dr. Conrad Bell, is so consumed by anxiety that he just hums constantly to keep his nerves in check. Throw in mathematical genius Dr. Stephen Okafor and a really tight-knit crew of engineers and technicians. So why are they operating in this state of total exhaustion? Well, 3 weeks prior, the Soviets tested a suspected boosted fission device over Siberia. Washington panicked. They slammed the gas pedal, accelerating the timeline and pushing these sleep-deprived, hypervigilant scientists into an insanely dangerous experiment before they were genuinely ready.
Their assignment, advanced criticality studies. Now, spontaneous criticality is a very clinical term for something horrifying. It is the exact threshold where nuclear material sustains a runaway, deadly fission chain reaction. The stakes here are absolute life and death. Their job was to take a silvery gray Fat Man-style plutonium sphere and push it right up to the very bleeding edge of a nuclear reaction. They were literally ordered to walk right up to the cliff edge of a nuclear detonation, peer over the side, take their measurements, and just walk away.
So, the plutonium core arrives in a shielded container and it's placed into an aluminum cradle. You have to picture this core as a silent, deadly antagonist sitting perfectly still under these harsh overhead lights. It demanded this profound, terrifying respect, and every single person in that room could feel it in their bones. In the background, the baseline measurements on the Geiger counter are just humming along. 2.1, tick, tick, tick. It sounded exactly like a sleeping dragon. But everything was nominal. Everything was completely ready for the test.
The mechanics of this test were just agonizing to watch. Here's how it worked. The plutonium core sits in a lower beryllium hemisphere. Above it, hanging on a threaded rod, is the upper beryllium hemisphere. Now, beryllium is critical here because it reflects neutrons right back into the plutonium core. So, as you systematically lower that heavy upper shell over the core, it traps more and more neutrons, which violently spikes the nuclear reaction. To put it simply, you are slowly closing the lid on a nuclear bomb just to see exactly how angry it gets before it explodes.
And that brings us to their terrifying goal, 4 millimeters. Dr. Stephen Okafor's mathematical models strictly dictated that they would lower this heavy shell until it was exactly 4 millimeters away from the core's surface. At that incredibly tight gap, his math predicted a neutron multiplication factor of 0.97. Since 1.0 means you've hit a critical, deadly nuclear chain reaction, 0.97 was considered a safe, measurable margin. The math had been rigorously checked, verified, and blessed by independent reviews. 4 millimeters was the absolute safety net. But as we're about to see, math on paper and the ruthless reality of the universe are sometimes two completely different things.
At 8:04 a.m., this claustrophobic drop begins. Raymond Cho carefully turns the long-handled rod, just a quarter turn at a time. Down it goes. At a 3.2 millimeter gap, the instruments read 0.71. It perfectly matches the math. They drop it to 2.4 millimeters. The reading is 0.79. Again, a totally perfect match. Down to 1.6 millimeters. It reads 0.87. Everything is absolutely flawless. The theoretical model is perfectly predicting the behavior of this deadly piece of metal. Eleanor Marsh is glued to the dials, and Conrad Bell is just humming his nervous tune.
Step 4, 0.8 millimeters. Raymond Cho turns the rod one more quarter turn. The deadly upper metal shell descends another fraction of a millimeter. The gap between the shell and the plutonium is now literally thinner than a pencil line. The tension in that room is completely suffocating, and the instruments begin to climb. 0.91, 0.92, 0.93.
And then, the anomaly strikes. The theory firmly predicted the instruments would stop at 0.93, but the dials just kept creeping up, finally stabilizing at 0.94, 1/100th of a point higher than this heavily vetted theoretical model. Now technically, Stephen Okafor points out that this is still completely within the accepted plus or minus 0.02 tolerance band. They supposedly still have a margin of 0.06 before they hit a fatal 1.0. The protocol says they are supposed to keep lowering it down to that final 4mm target. The math is telling them it is perfectly safe to keep going.
But Eleanor, she looks at the core, she looks at the dial. She asks Stephen just how confident he is in the math down at this sub-millimeter gap. Stephen hesitates. The experimental data is pretty thin down here. And right then, the most terrifying sound in the room happens, which is no sound at all. Conrad Bell, who had been humming continuously for 6 straight weeks out of sheer nervous terror, suddenly stops. Dead silence. The total silence of absolute dread. Eleanor trusts her gut right then and there, and she halts the descent sequence immediately.
The operation is instantly frozen. The immediate physical danger is paused, but this terrifying hanging unknown is just lingering in the air. Over the next 48 frantic, completely sleep-deprived hours, Eleanor, Stephen, and their team tear the mathematical model completely apart. They are hunting for an error, and finally, on day 2 at 9:45 p.m., they find it. Hidden deep inside the equations for the near-contact regime. It was this tiny, obscure boundary condition that was handled just slightly imprecisely. At large gaps, it meant absolutely nothing, but down at those sub-millimeter gaps, that error compounded dramatically. The room falls completely silent as Stephen finishes recalculating the corrected math by hand. Eleanor looks at him and asks the chilling question that challenges everything we think we know about safety protocols. What would have happened if she hadn't stopped? What did the real corrected model actually predict for their final 4mm target gap?
1.01. Remember, 1.0 is critical. 1.01 is supercriticality. It means a runaway localized nuclear blast. If Eleanor Marsh had authorized just that very next step, if she had trusted the original math and told Raymond Cho to turn that rod one more time, the core would have gone supercritical. A blinding flash of blue light would have instantly filled the room, and every single person inside Building 12 would have been subjected to a massive, lethal, agonizing dose of radiation. They would have all died.
They had been blindly marching straight into a catastrophic nightmare. They were aiming for a 4mm gap, but the revised, actually safe target gap, it was 9mm, more than twice the distance they had originally calculated. The only thing in the entire world that saved their lives was the physical instruments reading 0.94 instead of 0.93. That tiny 1/100th of a point discrepancy was the machines literally screaming at them that the math was fatally flawed.
Operation Sandstorm was immediately suspended. The models were completely torn down and rebuilt from scratch. And in her top-secret report following this horrifying near-miss, Dr. Eleanor Marsh wrote down this profound realization. The instruments were correct before the model was. In this line of work, when measurement and theory diverge, the correct assumption is always that the theory is wrong, not the instruments, never the instruments. She wrote, "The instruments are the only honest voice in the room."
She ended her report with a statement that honestly just leaves a cold pit in your stomach. She said, "Physics is not forgiving. It doesn't grade on a curve. It doesn't care how good your reasons were or how carefully you thought it through. When you are wrong, you are wrong. And the universe will demonstrate that to you in the most direct way available. A microscopic miscalculation almost cost 7 people their lives. Humanity was spared a horrific tragedy only because one exhausted scientist noticed a single 100th of a point on a dial and had the terrified wisdom to say, stop. But it really leaves you wondering, doesn't it? How many microscopic, deadly errors are hiding in the algorithms and the models that we blindly trust every single day?
We really do walk on a razor's edge every day, trusting the invisible math that holds our modern world together. But sometimes, that math is dead wrong, and only a humming dial can save you. If you want to survive more terrifying true science explainers exactly like this one, you need to hit that like button and subscribe right now. We've got way more gripping stories from the deadly margins of science coming your way. So stay curious, stay highly vigilant, and we'll see you in the next explainer.